Most of our electronic projects are being run by Arduino platform. It's an open source computing software that is based on a microcontroller board. It's like the main brain for most of our electronic circuits. And this does the stuff for it to be able to sense, move, and make it more interactive. Currently, we're working on robot suits. Huge, gigantic robot costumes that is being driven by a man. And whenever they move a limb, special sound effects would come out. Lasers equipped, cameras, drones following, and anything that you could imagine to make the robot more interactive and more appealing to anyone. Mig Acetron is the first robot that we're working on out of the three. He's 12 foot tall and is equipped with subwoofer speaker systems. So basically there's a man inside him and there's a camera pointing in front of the face. Then that camera has a microcontroller in it which detects the human emotions that the face is showing up. Like for example, whenever the user or the driver or the pilot moves its face, it syncs with the face, or it syncs with the head of the robot, Mig Acetron. Right now, I've been working on using a camera lens for Mig Acetron's eyes and trying to figure out the signals that you have to send to the lens so that the shutter or the iris would move. Here's a demo for the camera lens control. We've used some micro servos to control the eyebrows, and as you can see, the prime lenses are put up here. Then at the back of the lenses are two rainbow Arduinos that put up emotions. We followed the standard color pattern for the 7 basic emotions and those emotions are shown on these rainbow Arduinos, the output colors that we assign. So all of them are controlled using one Arduino board and a couple of power supplies. For a quick demo, I'll be turning this one on. And some wires to control the iris. Right there. Right now, we're still doing some research, continuous research on this to make things more stable and lessen all the mechanical, electrical errors. On the lower part of Mig Acetron, we've equipped him with some infrared lasers of distance sensors that whenever it raises its legs, there's a syncing sound effect that comes out of the speaker. What I'm doing now is creating a mixing sample for the sound effects for Mig Acetron's leg. Here's the part where it raises its legs. This part, this half-second sound waveform plays like that, and while the robot is raising its legs, this part of the waveform plays. Created an Arduino code that uses a looping sound so that if the leg stays up high, then it just loops. And this part, the 2 to 3 second part of the waveform, is where the robot stomps its leg. So a simple crashing sound. So after creating a mixdown, I've uploaded the file on an SD card, which is found here. The SD card is mounted on the MP3 shield with the Arduino, and I've created a very quick program to sense the infrared sensor that is connected to the input side of the Arduino. Then with the MP3 shield, the speaker system is connected right here. Then the speaker system is composed of a crossover tweeter amplifier, mid frequency, and a bass. So that's why the moment I raise this boots, a special sound effect would come out like so. So sooner or later we'll be integrating this one on two legs, and on the scaled part outside, testing it on the field. It would be very interesting to see a person on stilts with sound effects walking down the Bigfoot compound. Everybody would like all eyes on that. Next time we'll be discussing more on the other features of Megasatron.